बिस्मिल्लाहिर्रहमानिर्रहीम। आज हम पढ़ने जा रहे हैं एक फार्मर के सन की स्टोरी हु हैड 12 सन्स एंड डॉटर्स। तो कहानी है आज रदरफोर्ड की। रदरफोर्ड का जो फादर थे वो एक फार्मर थे और उनकी डिज़ायर थी कि उनके बच्चे जो हैं वो आला तालीम हासिल करें, इसीलिए उन्होंने रदरफोर्ड को एक अच्छे इंस्टीट्यूशन में एडमिशन दिलाया। तो रदरफोर्ड का बैकग्राउंड जो है वो कोई इतना ख़ास स्ट्रॉन्ग नहीं है। तो रदरफोर्ड इज़ फेमस फॉर हिज एटॉमिक मॉडल दैट ही presented. So let's see what Rutherford presented and how he presented his atomic model. जैसे कि पहले आप जानते हैं कि एटम ऑलरेडी डिस्कवर हो चुका था कि एटम इज़ फंडामेंटल पार्टिकल ऑफ मैटर and there are protons, positively charged particles, and electrons, negatively charged particles. जो previous view था plum pudding model, that was that electrons are embedded within the atom. What does it mean? पुराना कंसेप्ट ये था कि जो इलेक्ट्रॉन्स हैं, यहाँ कर लेते हैं कि इलेक्ट्रॉन्स जो हैं like they are negatively charged and they are embedded in a pudding like plum. प्लम कहते हैं आलू बुखारे के टुकड़ों को। आलू बुखारे के टुकड़ों को अगर आप पुडिंग में या कस्टर्ड में कहीं कहीं स्प्रेड कर लें तो वो आपका प्लम पुडिंग मॉडल बन जाता है कि इलेक्ट्रॉन इस वे में डिस्ट्रीब्यूट है। जस्ट एज हम समझ लेते हैं वाटरमेलन। Now this red portion, say it is proton, and these seeds somewhere else, these are the negatively charged particles or electrons, and they are distributed in such a way. So this was the old concept. Similarly, you can take the example of guava. Say that these seeds are negatively charged particles or electrons. They are embedded within the positively charged proton. Okay. Now, what was Rutherford experiment? Rutherford experiment is actually based on gold foil. He took a gold foil, and that gold foil was 0.0004 centimeter thick. It means he took a very thin gold foil, and the purpose of taking this thin gold foil was because he wanted to have very small amount of atoms in it. This gold foil contained near about 1000 atoms in it. Then he took a lead block. Okay, here I've shown you a lead block. He used a radioactive element, radium or plutonium. Radium with atomic number 88 and plutonium with atomic number 84. These radioactive elements are those which emit continuously radiations. And the purpose was to get alpha particles of high energy. Now, what are the alpha particles? Alpha particles are actually the helium nuclei. You know the atomic number of helium. Atomic number of helium is 2. So its atomic configuration is, atomic structure is such that 2 electrons are present in the first shell. Now there are 2 protons and 2 neutrons. 2 protons and 2 neutrons in helium. When helium gives its 2 electrons, it becomes helium plus 2 helium nuclei, and these helium nuclei were 20,000 in number. He took a very small slit in the lead block so that a very small beam could emerge from it. He observed that this beam of light that was originated from radioactive element, it traveled in a straight line, and after hitting this gold foil, what happened? He saw many observations. He saw that majority of the rays, they move in a straight line, okay, and they hit the inner wall of the zinc sulfide coating. This is zinc sulfide coating, a fluorescent material. When the rays hit with it, a shine appear here. So majority of the rays undeflected pass straight through the gold foil. This was the his first observation, that majority of alpha particle pass through foil. Second is that few of the rays were deflected at small angles and large angles. So there are shown some rays which are deflected at small angles and other at large angle. This is the second observation. The third observation by Rutherford was that some of the ray, it doesn't show any deflection, minor or major, and it didn't pass through the gold foil. Rather, it rebounded back, it bounced back. क्या हुआ कि वो वापस टकरा कर वापस आके, just as you hit the ball on the wall and the ball comes back to you, it means something, ball has struck something else which was hard, and it rebound back, action and reaction, Newton's third law. So this ray, it rebound back. This was the third observation. Now why is this so? The conclusion, this is the observation. Now the conclusion is, why is this so? Why majority of the rays, they pass straight through the gold foil? He concluded that majority part of the atom is empty. The atom का जो majority part है, it is empty. That's why the rays, they pass straight. Okay. Second is the size of nucleus. Second is the size of nucleus is very small as compared to atomic size. He observed that major and minor deflection occurs because these rays strike with something that is present in the center, and it is a dense hard sphere, and that dense hard sphere was said to be as nucleus. Okay, and then he concluded that this ray, the third ray, rebound back. Why? Because the size of nucleus is very small as compared to the total size of the atom. So these were the conclusions by Rutherford. And later on, you will see the defects also of Rutherford. Rutherford not only he presented this atomic model by himself, only he worked with J.J. Thomson also, who was his teacher, and also two other colleagues worked with him. but the majority work was done by Rutherford, and he was born in New Zealand, and he came to UK, worked with J.J. Thomson, and then due to certain reasons, J.J. Thomson advised him to go to Canada, where he continued his work, and then he returned back. Okay, inshallah. Next, we shall see the drawbacks of the Rutherford atomic model and how more advancement were seen in case of atomic model further. Thank you.